All right, we'll go ahead and get started this morning. I'd like to welcome you to Waiting for Wireless. What we'll do today is take you through a little bit of the technology behind wireless, and then we've got two presenters here this morning to give you case studies of, in one case, how they've implemented a Radiolan 10 megabit per second wireless network, an install that has been going for 18 months. Gregory Ivy from the SMU School of Law, Underwood Law Library, where he's Associate Director, will take us through that installation. And then we've got Gary Moore from Hofstra's Law School, where he's the Director of IT, who will take us through his imminent implementation of Cabletron, a standardized 11 megabit per second product. Before I get started, I just want to poll the audience to see who we've got here and what the interest is. For those of you who are in C50, just yell really loudly so that we know what your responses are. How many law faculty do we have here this morning? Okay, how many law librarians? And IT staff? Wow,
pretty even.
How many people are waiting for wireless?
Wow.
How many people are already either they've bought a product, they're implementing a product, or they have a live network? How many people are the skeptics who are never going to go wireless? It's always fun. My name is David Whelan. I'm from the American Bar Association Legal Technology Resource Center. I'll give you a brief overview of the technology. If you'll hold the questions till the end, we'll be happy to answer any and all questions related to the presentation or not at that time. I'm going to go through quickly so we have as much time to hear about the case studies. And if there's something about the technology that I gloss over too much and you don't understand, feel free to come up and ask after the presentation. What are we waiting for? You hear the term wireless a lot. You may think of cellular phones. You may think of other wireless devices. What we're talking about today are wireless local area networks. Wireless local area networks use access points, which are antennas that are generally attached to the ceiling or somewhere high so that they can pick up data transmissions from as many users as possible. And your users have an antenna on their computer or on their handheld device that communicates to that access point. So we have the computer or the laptop, the handheld device with the antenna, and we have an access point somewhere suspended, preferably above you. The access points will have some sort of electrical power, and they will have a wire connection to your hub. So when we talk about wireless, we're not talking about getting rid of wired networks. This is an adjunct to your wired network. And then your laptop or your computer will transmit with the antennas from the local machine up to the antenna in the ceiling, the access point. Now, there have been a number of reasons for waiting. I was involved in the SMU install where we installed a product about 2 years ago. There are still reasons for waiting today. We ignored some of them, and some of them have changed so that it would be worthwhile looking at today. They include that you'll get less bandwidth with a wireless network, slower speeds than you would with wired. There has generally been a lack of standards, although that is quickly changing. Cost, it's much higher for a wireless network. And there have been too few users to really demand the need for having wireless access in your building. Some of that is changing, but it still may not be enough to push you over the edge as far as wireless. Current wired networks can get 100 megabits per second for bandwidth and faster. Wireless products right now are running 10 or 11 megabits per second. In the 2 gigahertz range, the maximum will be 25 megabits per second. In the 5 gigahertz range, with the 802.11b, 802.11a, and Hyperline standards, you're going to be getting up to 54 megabits per second. So you're never really going to be hitting, with the standardized products, the same level you'll be getting with wired. Additionally, you may not even be getting what you think you're getting as far as the speeds. Wireless networking bandwidth not only drags behind wired network, but the access points will segment the amount of access you get depending on how many people are hitting it at the same time. So what that means is that if we have a wired network that has 10 megabit per second throughput, if you have 5 users, each user will be sitting at a computer and connecting at 10 megabits per second going over the wire. If you have wireless that's also 10 megabits per second, if they all 5 hit the access point at the same time, then you're chopping it down into 5 pieces. Wireless standards have been an issue. The first wireless standard came out in 1997, 802.11, just straight. It really applied only to 2 megabit per second products, and without a standard, we had a lot of products that couldn't work together, and it made it a very difficult issue to buy wireless. As of last year, we have the 802.11b standard for 2.4 gigahertz, 802.11a. Hyperland 1 and 2 standards are under development. There's the Bluetooth standard, and there's the Home RF group. Now, again, what are we talking about today? We're talking about wireless local area networks. So we're really talking about these three right here. We're not talking about Bluetooth, and we're not talking about Home RF. Personal area networks and home area networks may have some applicability in your organization. You may have a use for them, but technologies like Bluetooth have a very small coverage. So you're talking about 30 feet between appliances. It's meant to allow you to synchronize or use wireless between your handheld, your PC, and other appliances. In Home RF, it's the same idea. You'll be able to talk to your microwave with your laptop. Another stalling point on going with wireless has been the cost. Cost for wireless networking is now dropping very dramatically, and it is now much more easy to justify either buying for your organization or suggesting your students buy for themselves the antennas. These days, you can buy a NIC for your laptop, a PC card, starting for about $90. In 1997, an antenna for a wireless network was about $1,000, and those prices have now dropped to about $200 per card. So the price is still not the same for wired and wireless, but you're a lot closer. It's a lot easier to justify. Now, reasons for wireless. You've been listening to me stand up here and say all the reasons you don't want to go to wireless. I'm surprised you didn't all walk out of the room. Why am I here for the wireless? Wireless has a lot of possibilities, a lot of reasons that you should be using it as a way to deliver more services to your users, either faculty, students, or if you have public patrons. One of the reasons that wireless is a good, usable feature is its security. Data transmission is as secure, or some will say even more secure than on wired, because of the way the data is transmitted from the antenna to the access point. It's very difficult to know the information that you would need in order to grab the data as it flies past. In addition, you have the ability to use WEP, wire encryption. Is it protocol?
Wired equivalent privacy.
There we go. WEP. To encrypt the data as it goes by, 64-bit encryption. And you can also hardware control the access points so that only certain antennas can communicate with certain access points. Wireless has the opportunity for your organizations to go more mobile, allow your users to take their computers everywhere in your institution, in your facility, and it will allow you to consider options for outsourcing some of your technology. Now, outsourcing is a scary buzzword. When I worked at SMU, it was something I avoided like the plague. But it doesn't mean outsource your technology support to other people. It means outsource your technology purchases to other people. And what that means is get wireless, and then you provide the network connectivity, and you get your students or your other people to buy the laptops, which then connect to your network. So you're providing the network resources, you're providing the connectivity, and then you push the operating system, the laptop, whatever it is, out to the user. Another reason to start considering wireless, if you haven't already, is that there's now a lot of momentum among vendors. There's a significant focus by networking vendors on the wireless market. Recent acquisitions by Nortel and Cisco of wireless vendors is a sign of the times. Organization of large vendor-focused internet interest groups, including the Wireless LAN Alliance for the 2.4 gigahertz range and the Hyperland 2 Global Forum. And attempts at certification processes like Good Housekeeping Seal of Approvals by the Wireless Ethernet Compatibility Alliance. And I'll let Gary talk more about that because that's from his standard-based product. Infrastructure improvement. Information Week in 1999 cited statistics that said if you have a wired network, 35% to 75% of your network issues can be related to your cabling. So we're talking about potentially reducing the amount of network problems you have. You're eliminating breaking wires, the entire piece of data transmission between the access point and the antenna and the ceiling. And then facilities costs. Both of the speakers today will tell you the amounts of money that they have potentially saved by going with wireless. The cost that you have up front with wireless products is a little bit higher. The cost savings overall may be a lot more significant than just the dollar per dollar value. And what we mean is that there are significant saving costs in furniture, in avoiding asbestos removal, in not having to pull wire and electricity into all of your rooms. There are all sorts of opportunities there. So with that, I'll just say a word about what I think the future of wireless is, and then I'll pass it over to our panelists. I think you'll find that in the future it's increasingly cost effective. It'll be increasingly fast as we hit 54 megabits per second or faster. It will be available on many devices. Zircom will have the first springboard 802.11b compliant antenna for a handspring visor later this year. It'll move into the 5 gigahertz spectrum, where there's a lot more space. So right now, when we're talking about radio spectrum, generally the wireless products are falling into two areas: 2.4 gigahertz and the 5 gigahertz range. Right now in 2.4, we've got all the 802.11b products. We've got Bluetooth, home RF, we've got your microwaves, and your garage doors. In the 5 gigahertz, we're looking at 802.11a and the Hyperland products. The nice thing about Hyperland that will take us a step beyond the 802 products is that Hyperland products can go ATM, they can go Ethernet, they can do a lot more interoperability among different types of wired networks. And with that, I will pass off to Greg Ivey.
Thank you very much, David. I'm very pleased to be here today to tell you about SMU's experience in wireless networking. And one of the reasons I'm very happy to be here is because I do consider our installation to be a very successful use of technology for at least a couple of reasons. First of all, I think it proved to be very cost effective, but also it really made a difference to the users of our library. And I think that's one of the most pleasing aspects when you adopt a new or relatively new technology. Let me begin by giving you a little background about the Underwood Law Library. First of all, the law library is located in a law school at a private university. The library building is about 100,000 square feet and houses at this time about 535,000 volumes. The building was completed in 1971, and as typical of most buildings that predate the 90s, it was not designed in any way to accommodate network wiring. The library serves approximately 40 law faculty and about 770 law students. The law school's computer lab is located in the library building. It contains 41 desktop PCs, and in addition, at least back in 1998 when we were implementing the wireless network, we had 5 laptops that we kept at the circulation desk, which were available for students to check out and use inside 13 wired carrels. The network inside the library is an Ethernet network, which is maintained by our campus IT department. In probably 1997, maybe a little bit earlier, we began to realize that there's certainly a need for additional network computers. We had the 41 lab computers, 5 circulating laptop computers, and those were adequate for users, I would say, more than 95% of the time. But there were those periods of peak demand when there were large 1L assignments, etc., when we didn't quite have enough computers to meet student demand. Also in the mid-90s, we saw, as did you, an increasing number of student laptops, and of course we knew that trend would certainly continue. As we looked around for options as to how we could expand the number of network computers we had in the library, we saw that there were at least 2 options. The first option was to enlarge the computer lab and increase the number of the university-provided computers. We were not eager to do that, first of all, because the number of computers we had were adequate almost all the time, and we certainly didn't relish taking on the ongoing maintenance of having a larger number of computers. The second option was to facilitate network access for student laptop computers. This seemed to be the more forward-thinking approach, and we were eager to try to accomplish that. We began to explore how we could actually hardwire the entire building. The network wiring up till this time was concentrated in the student computer lab and in library staff areas. We explored various options, some of which you have probably gone through, such as drilling through our concrete floors, trenching through the floors, perhaps bringing wiring down from the ceilings in unsightly vehicles, etc. We really were not eager to pursue any of those avenues, quite frankly. We had over 700 student seats that we would like to wire, and ultimately, after we obtained some cost estimates, we discovered that the cost for wiring over 700 seats would be in the range of $500,000 to $800,000. Well, that was one issue. There was, of course, the other issue of how you provide network jacks at 30-year-old study tables such as we have in our library. Those study tables were probably reaching the end of their useful life. They certainly did not have any sort of facilities for network wiring. Did we really want to spend the money retrofitting a lot of study tables for network outlets? And I think we answered that question very easily by saying no. Well, the solution for us arrived in 1998, and it arrived in two waves. First of all, the law school was the recipient of a $1 million technology grant from the Hillcrest Foundation of Dallas. That certainly started us on our way. And the other part of the solution is that we became aware of the Radioland wireless network product. Back in 1998, that was the only 10 megabit solution for wireless networks. As we began to explore the wireless technology, we had the typical concerns that you would have anytime you're trying to implement what is basically new technology. And I'm not going to cover all of these, but certainly I'll concentrate on performance. We were, to say the least, skeptical that we could really achieve the 10 megabit performance that the manufacturer touted. We wanted to be able to have a solution that was comparable to the Ethernet that we had in the entire law school. And of course, the Ethernet standard in 1998 was 10 megabits per second. We were also concerned about compatibility with the campus network. We were very concerned about support. We realized at some point hundreds of our law students would have laptop computers, and that could create an immense support nightmare for our staff if the wireless solution wasn't as support-free as possible. Needless to say, we were concerned about security. When you install a wireless network, you have at least an initial fear that people may be able to get into your wireless network and do hacking that, of course, you would not want to see. And, of course, we were concerned about scalability as well, since we might have potentially hundreds of users. Well, in the beginning stages, we didn't know exactly what the cost would be. The overhead here shows exactly what the cost turned out to be, in fact. We installed 16 access points at a total cost of about $11,000. We ultimately purchased about 50 antennae at the cost of $395 each for about $20,000 total. And then the cost of the access points turned out to be about $10,000. Let me say that in the intervening time period, the cost of the antenna have gone down to about $299 list. Radioland was offering these antennas last week, and I believe this week as well, for $180 each. So that's an area where you could save money today. Also, in terms of installation of the access points, that included not only the physical installation of the access points in the ceiling, but it also included the installation of network wiring to those access points as well as AC power. Well, before we made the decision to actually install the wireless network, we decided that we wanted to test it fairly rigorously. So we purchased a Radioland starter kit, which consisted of 2 Radioland access points, 2 antennae, and the Radioland software. Our IT staff connected the antenna to 2 desktop PCs, put the desktop PCs on book carts, and rolled them around the library to test and see just how good the data transmission rate would be. We were also concerned about obstructions, which I'll talk a little bit more about in a few minutes. In any event, we were very impressed by the test results. We were very impressed by the data transmission rate, and we did find that there were few obstructions that affected data transmission. Well, we decided to go ahead and implement the product in probably mid-1998. Implementation began with the site survey, and we determined that we should probably install 5 access points per floor. The overhead indicates a floor plan of a typical floor in the Underwood Law Library, and we installed the access points at the points indicated by the stars. Now, from an engineering standpoint, this is complete overkill. Probably 1 access point should cover this particular area. The Radioland product access point will send and receive signals for at least 120 feet up to 10 megabits per second. However, in our building, we have a number of load-bearing walls scattered throughout the building, and we were concerned that that would create some obstruction of the signals. And so therefore, we really over-engineered this thing by putting in 5 access points per floor. One of the initial issues that we had to cross was how were we going to assign IP addresses to all the student laptops. Our model up to this point had been static IP addresses assigned to permanently installed PCs. Obviously, this was going to be a new situation. We didn't really want to have to go through the support measures of assigning IP addresses to every student with a laptop, nor did we want to use up a large range of IP addresses, so we elected to use DHCP. Some of you know that DHCP is a protocol which allows the dynamic assignment of IP addresses. For example, if a laptop user connects to the server will then dynamically assign an IP address from a pool of IP addresses resident on the server to that user. The user will use that IP address during that session, but when the user logs off of the server, that IP address is then returned to the DHCP server and will be ready for the next user. We also decided that we would require users to authenticate themselves by logging into our NT server. This is exactly the same system that we have in our student computer lab. Once we installed the access points, it was time to test the system prior to releasing it to all the students. And we began to test it by soliciting a small group of students to serve as a test group. They were students who were certainly above average in technological proficiency, and they were very excited about being part of this test group. They tested the system for probably 2 to 3 weeks. They went through fairly rigorous measures, trying to get as much bandwidth as possible. And needless to say, the test results, in our case at least, were very good. There is another aspect, of course, to implementation, and that is the client software that has to be installed on the laptop computers. Radioland does have its own software. There's also the Microsoft Network client software that has to be installed. But this software has to be installed and configured only once. Now, let me say a couple things about performance. The first thing is returning to the topic of obstructions. Radioland warns, and I'm quoting here from their manual, that walls made of metallic substance, thick concrete walls reinforced with metallic studs, foiled back insulation installed within walls, desktop objects that surround your Radioland transceiver may create obstructions that decrease range. As a practical matter, probably because we've over-engineered in terms of access points, obstructions have not been a problem for us. One of the things that librarians certainly worry about, and that is whether or not book stacks will create obstructions. Well, obviously, our library is full of book stacks. Our book stacks are made of metal. The end panels of those book stacks are metal, and we really have very little problems with obstruction. There are some corners that you could get into where you might run into a problem with obstructions, but generally speaking, that has not been an issue. The Radioland product does operate in the 5.8 gigahertz range, which actually serves as an advantage to some extent. David alluded to the fact that there are other appliances, including some of the new wireless local area network products that operate in the 2.4 gigahertz range. But then again, so do other products such as cordless phones, microwave ovens, baby monitors, and other products as well. The photograph on the overhead indicates what the access point looks like. It's not very visible in the photograph, but it's very small and very unobtrusive. Most people would not notice the access point at all, and some of the people who have seen the access point confuse it with a smoke detector. In terms of the client antenna, and by the way, we're using the term loosely, it's really a transceiver since it both receives and transmits radio waves. We have kept our client antenna on reserve at the circulation desk. The antenna are packaged in a plastic bag which also contains a diskette containing the client software, printed instructions for installing the software, and also instructions for printing over the wireless network, and it contains the antenna itself. We circulate the antenna for a 4-hour period. Initially, we set it up to circulate the antenna for only 2 hours, but we realized it really was not a long enough period of time. We've been very pleased by the minimum level of support that has been required. I can't tell you exactly what has caused this, but certainly part of the reason we've had to do so little support in terms of laptops is that we've really thinned down the client software installation. The software that comes from Radioland is fairly fat in that it contains the software for various platforms. We deleted all the software for the platforms that we don't support at our law school. And we tried to slim down the package so it would be small enough that it would be quick to install and not take up much disk space. I'm also happy to say that so far, at least to my knowledge, we've not had a single theft of an antenna, and we've had very little breakage of the antennas. What breakage we have had was exactly what you'd expect. It would be at the either the cord or the little card that plugs into the PC-MCIA slot of the laptop computer. Periodically, we have to reset the access points. It's just a matter of turning the power on and off, which that's the reverse order. Actually, turn it off then on, which is to be encountered, of course, with any computer hardware. Also, I'm very happy to report that we've had no security issues arise so far, and this probably arises from the fact that the users do have to authenticate themselves through the NT server. Going forward, this may also be assisted by the fact that Radioland does operate in the 5.8 gigahertz range, whereas some of the competitors' products will be in the 2.4 gigahertz range. This means that when people bring in a standards-based product into the library, that is a standards-based antenna, for example, with a laptop, if they try to get on our system, they wouldn't be able to do it because they'd be operating in the wrong frequency. We have run into just a few problems. For example, shortly after we implemented our wireless network, the campus network department decided to upgrade our network to ATM. This caused some initial glitches that were sort of sporadic in nature. It took us a few days or maybe even a few weeks to figure out the exact nature of the problem, but ultimately we figured out the problem and resolved it very quickly. Also, initially we received a batch of bad antennas from Radioland that gave us some sporadic problems, but those were returned and replaced. And we did have at least one access point that's failed in the last 18 months. The hit list, though, is much longer than the misses list. This has been a product that was very easy to implement. It's been very reliable, very fast, and has required very little user support. I have to say that from a pricing standpoint, especially when you consider the price of having to wire the building, to replace the furniture, this certainly has been a very excellent price value. Probably the most important thing on the hit list, though, is the level of student satisfaction. I have to admit that in advance of the installation, I was very concerned that the students might perceive that this wireless network was something that was somewhat less than a hardwired network installation. I would have to say that the result has been just the opposite. The students view this as something that is very futuristic, very forward-thinking. I think they're very excited about being able to use their laptop, their own environment, anywhere in the building. I do mean anywhere in the building. They can roam throughout the building rather than being tied to a specific table. They can sit on the sofa and still surf the web or do Lexis and Westlaw searching. Well, what is wireless's future at the SMU School of Law? This summer we are installing access points in 2 other law school buildings, at least in student areas. The cost for this extension of the wireless network will probably be in the range of about $8,000. We may install an access point out of doors. You may wonder why we would do that, and the answer is because we can, I suppose. For probably less than $1,000, we can install this out in an area where students tend to hang around outside, and there might be some marginal benefit to that. Initially, we had planned to install access points in all of our classrooms. At this point, we've installed them only in one classroom, a very large classroom. And quite frankly, the reason we've not extended the wireless network to all the classrooms is that we've really come up with no pedagogical basis that would require that. We've debated this quite a bit. In fact, that could be the subject of a Cali program in itself. But we just can't see any particular reason for students to have network access in the classrooms. Obviously, our instructors all have network access in every one of our classrooms, but student access is another matter. One other thing that we're looking forward to, and that is that Radioland claims at least to be planning to introduce a 100 megabit product in the near future. It was scheduled for release last month. Release has not taken place. The 100 megabit product, by the way, is based upon there being 10 channels, each channel transmitting at 10 megabits per second. So Gary will be talking in just a couple minutes about his standards-based system. Let me just close here by talking a little bit about the fact that our system is a proprietary system, and do we have any regrets about implementing a proprietary system versus a standards-based system? Well, back in 1998, when we implemented our system, we knew that standards were under development and that there would ultimately be standards-based systems on the market. However, we knew that that would take a while before those products would be on the market, and so we were not willing to wait that period of time. Looking back, by going ahead and installing the Radioland system, we have avoided an implementation delay of at least 18 months, which in IT terms, of course, is an eternity. Also, the Radioland product is, of course, proprietary, but it still has a very good data transmission rate. If you're considering a wireless network, or whether or not you are, you would certainly want to review PC Magazine's review of wireless networks in the April 18th issue. And in their test, they found that the Radioland product actually transmitted data at 25% faster rate than the proprietary products. There are also advantages of our system since it operates at the 5.4 gigahertz rate. I've talked about that earlier in terms of the added security, and also as a result of reduced interference. There's one other question which David alluded to, and that is standards. There's really not one standard, although some of the other standards aren't directly applicable to your installations, I would say. But all the standards are evolving, and you know how that goes. If you're waiting for a standard, the standards never will be static in any event. I guess the worst case scenario would be, what if Radioland went out of business? Where would we be then? And I guess I would respond to that by saying that as with any computer-based technology, we're going to have to upgrade the hardware at some point anyway, so we'd certainly continue on as we are, I'd say, for several years. Certainly in terms of our installation, the network wiring to the access points, the AC power to the access points, that was represented most of the cost of the installation, and that would still be usable going forward if we were to switch out systems. So I'd like to close at this point by making just 3 quick suggestions. First of all, DHCP worked very well for us in terms of providing IP address. This is for network access. I certainly want to encourage you to minimize user support by simplifying the software installation to the greatest extent possible. You can imagine when you have multiple hundred users, this will really be the greatest point of support. And to the extent that you can simplify it, you'll be doing yourself a big favor. And also, as I think David alluded to, I would encourage you to view wireless networks as an adjunct or a supplement to a wired network. I don't think anybody would say that if you're going to build a new library building today, that you would install only a wired network, a wireless network. You would, of course, install a wired network. But for retrofitting a network onto an existing building that doesn't really accommodate the wired network very readily, I think wireless is a great supplement.
While we're switching over, I just want to introduce myself. I'm Gary Moore. I'm Director of Information Systems, Boston University Law School in New York. I face many of the same problems Greg did, and I'm certainly not going to diss his choice. Radioland is a very good product. I recommend it for some of you who may not want throughput. You want throughput instead of standards. There we go. I can't see it on my screen. As Mitch Davis might say, damn Dell. All right. I guess we'll go through here and... Oh, actually we got it. Good. All right. Background of the law school in New York and Hofstra. We have 40 full... Let me get my mic on here. We have 40 full-time faculty and about 850 students. The university maintains the network, like SMU. However, the law school info systems, which is myself and my assistant and several student aides, we're a small department, unfortunately, create network accounts, and we monitor our own network. Just about all faculty, staff, and administrators have computers with 10/100 megabit per second connections on the law school network. Recently, in the past year or two, we've done a lot of restructuring, of rewiring, getting rid of our old Cat 3 and replacing it with Cat 5. We also had a bond issue where we had all faculty and administrators had new Pentium Dell, Pentium 3 450s, which seem like nothing now. It's amazing what a year does. Okay, we upgraded also 2 labs last summer with 36 450 megahertz Pentiums, also in the law school network, where students have to log in. About 2 years ago, we added 120 public access network ports in the law library and student lounges. We saw what Greg saw, and that we were going to be running low on resources, and that we wanted to try and shift it to the students. A lot of students had their own laptops, had already gotten, and had some network cards, were coming from undergraduate institutions, and we wanted to give them access to resources that we had on the network, but we just didn't think that we didn't have the space nor the money at the time to build more labs. So we did that also through DHCP. As I said, all classrooms also have at least one network port right now. And like I said, we have a DHCP network. Similar reasons that Greg had. It was much easier to give the student who had a card an IP address. We originally, when we were doing the public access ports, we wanted the students to log in their network accounts. But 2 years ago, we found the Novell client. We are a Novell network operating system shop. We found the Novell client to be very problematic in some of the laptops. So we went strictly with DHCP, and they're using their own Microsoft client for networks for the time being. However, the Novell client seems to be much more stable now, and we're planning to have them all upgrade the Novell client in the fall, any laptop user. Okay, so anybody who's going to be snickering here about that one EMAC, In the past 2 years, we've been renovating and, like I said, restructuring our law school network. Been pulling out most of the Cat 5. The last section of Cat 5, you see that one MAC 8 is being removed in this August. So stop snickering now, David. And basically, we're running either 1 gigabit or 100 megabits back to the university network core. Okay, background of our wireless project. Okay. Yeah, you heard that crash sound. We wanted to become a wired school. I made that on purpose to do a crash sound, because I'll tell you why. We wanted to integrate technology more in our classroom. We think what's coming down the road. We have already 2 classes, our entire third year New York Civ practice and our law and cyberspace class. All their resources are on our website. We have a lot of other faculty now are using Twin and Lexis in a Box, or Lexis Web Course in a Box, whatever they call it. And also we have a lot of legal writing instructors who are trying to implement technology in the classroom. So we wanted to invest... I shouldn't have only sound. We want to integrate technology, as I said, more than we were doing. We wanted more Ethernet access in the classrooms. And we wanted to add to our existing number of public access network ports in the library due to increased demand. The problem was, and you're going to see in a little bit, is we had some building problems. And like I said, we wanted all our students to have access to resources, network accounts, internet, network services, and printing. So we decided to look at wired versus wireless. I'm going to turn off my sound for now. I'm sorry, I didn't know I'd done that for every thing on there. Okay. Data wiring costs. At the law school, or as Dave Whelan says, the 20% markup in New York, we pay on average about $250 a port depending on location. And that could be often cutting through concrete, a lot of the similar problems. We have a lot of heavy brick, concrete walls. The school was built 30 years ago in that, somebody said that brutalist structure, or somebody said it bricks and bytes. Okay. Electrical wiring costs, that might be a little more than that. It might be $100 an outlet, depends on where it is. But also, when you're adding more ports and you're adding more outlets, you're going to need more circuit lines. Okay? So there's an additional cost right there. Furniture costs. That's the most expensive part. When I was looking over the wired, I'm going to show you a little bit how we did our Simon Moot courtroom, which we did wire. Very expensive. The furniture kills. Electronics. If you're going to wire a receipt, that means you're going to need additional switches. You're going to need additional boards and current switches, if you should be lucky, patch panels, etc., etc. That's very expensive, and I'll show you that also in a second. Building problems. Only 2 classrooms and 1 seminar room are completely wired right now because of the costs. All 3 of those rooms were donated money. We have 5 classrooms and 3 seminar rooms that needed to be wired. So that's a lot. We also, just like Greg, have a lot of old carrels that are not wire access, no power to them, no data ports, very old carrels. So the pictures you're about to see, you may cringe. I know I did. As Marvin the Martian might say, isn't that lovely? Okay. That's the carrels we have. A lot of them are right in the middle of the library. They're not near a wall. You'd have to be cutting through concrete and expensive as hell. And as I'll tell you in a minute, we just didn't have the money. Another wonderful picture. I cringe right now I see this room. Old tables. Certainly you can't run, conduit under the tables. It's brutal. Okay. We just renovated a courtroom, our largest classroom in this past fall, and it's called the Simon Moot courtroom. We have 200 seats in the room, and there's an outlet and network port in every seat. The furniture cost $150,000. I kid you not. It's expensive. And anybody that's dealt with the KI furniture knows what I mean. And there are other companies that do that. Data wiring costs of every seat, we were fortunate. It was only $20,000 because you're able to run the data, the conduit through the tables. Electronics. A new hub with 192 ports, $52,000. Electrical wiring about 30. I think I'm underestimating that. I'm being conservative. Because I'm not including the cost if you're going to actually renovate a classroom, dimmer switches, putting in dimmer modules and all that. That's an expensive cost too. I also didn't include the cost of putting in you'll see here, over $250. I didn't even put in the cost for mounting an ceiling projector and the screen, the projection screen. So it's probably close to $300,000. And that was about half our budget for that room. And that's one classroom, and like I said, donated money. And we're a 30-year-old law school. We don't have the, I hate to say it, the alumni endowments that a lot of other older schools have. I mean, I wish I could have done a building, but, we could do a new building like Suffolk. It's not happening right now. Conclusion, wiring every seat. We simply did not have the money to wire every classroom and every carrel in the library. We needed another alternative, thus we looked at wireless. My concerns for a wireless network to work, and for you skeptics in the room, I was a skeptic too. I had read the technology. I thought it was 1 megabit, 2 megabit per second. That's what I had heard. And I like to call Dave Whelan my wireless evangelist because he made me from a skeptic to a believer. And I'll tell you more about that in a second. Speed had to be in the 10 to 11 megabit per second range. Reason. We're going to be offering resources to our students. Even though it might mostly just be email and the internet, we do want them to be able to log in, and we want them to be able to save their directories on the server. We want them to be able to use our printing services. That was important. It had to be in that range. Range, ideally you'd like it to work up to 500 feet. Yeah. If we got relatively close, we were pretty happy. Because, obviously we have a large building. We're concerned, when we're doing this, we're wiring doing wireless in our entire building. We wanted to try and keep the number of access points to a minimum. Reliability, easy install, tech support, and maintenance. Obviously you want it to be reliable. I mean, if it works some of the time, why bother? The idea was that we wanted a product that when it dropped in, when you increased in range, even though you dropped in speed, the transmission data rates were still not even only acceptable, had to be damn right, almost perfect. Easy install. One of the things we're doing with this network, with this wireless network, is that if we're going to have wireless cards and we're going to want our students to be using these resources and use the wireless network, it's going to have to be relatively easy install. That's the first part. The second part has to be easy install on my end. I can't spend, hours upon hours setting up an access point. And the access point I chose, in fact, all the access point, the wireless companies, it was a snap. And I'll tell you about that in a second. Tech support. Like I said, we're a two-person shop. We don't want to have to be going around, if the install for the network cards is very difficult for students, we don't have the manpower simply to do that. Maintenance. What I mean is I want a maintenance plan. I want to be able also to have upgrades, because I know it's not going to always be 10 to 11 megabits per second. I want to have 24/7 tech support if I need it. I want web support if I need it. Cost. Very important here. For us to justify it, it had to be significantly less than the wired, but even more important, the cost to the user. If we're going to have students use our wireless network, the cost had better damn well be in the range of a wired card. Because I know my students, I work with students a lot, and they simply will not pay for it. A card that was, $200 to $300 more than a wired card. Standards versus proprietary. This was always in the back of my mind. This wasn't my main concern. But did we want to use an 802.11b standards because I saw the standards coming, or did we want to use a proprietary solution such as Radiolan? It needed to work with our existing hardware and network environment relatively seamlessly. I can't afford to have my network crash. Very simple. Wireless solutions we looked at. We looked at 3 at the time. More have come out since then, but remember we started this last fall. Radiolan, Aranet 4800, which was recently bought by Cisco, and the Cabletron Roamabout, which is the one we eventually chose. All 3 are shared 10 or 11 megabit per second products, so they match my requirements. The wireless evaluations. Very simple test you can do. Well, first thing we did as evaluations, we talked to other schools. David was one of the first people I talked to, and my law library director had gotten in touch with, your law library director. I guess maybe I got in touch with Greg or whatever, and had suggested me to talk to David. David was one of the first people I talked to, and like I said, he made me from a skeptic to a believer. But I talked to a lot of other schools. I talked to Boston College, actually some of you in the room about Princeton, I don't know if there's anybody here from Virginia, but I spoke to somebody in Virginia. This Florida public school system, I talked to people about that. A lot of people were using wireless. A lot of people were happy with it. So it had some viable uses for me. Ran evaluation units on each product, and these are simple tests that you can do. Ease of installation on the access point and the laptop card. That was one of the tests. I'll tell you the results in that in a second. But like I said, you didn't want to spend much time setting up the access point or setting up the laptop card. Trace route and IP address. You want a simple test of how fast your wireless unit is? Do it like a set address on your network and do a trace route on it. Download a 6 megabyte file off the network. You'll see good results on that. You'll see results on that. Do a range test. And do a range test throughout the entire building. And for those of you who are you're going to do wireless and you want your students to purchase wireless, my best test is walk through the library. Believe it or not, some law students are inquisitive. They were curious about it, and they asked me what I was doing. And in fact, after weeks later, people would come up to me and say that I knew I didn't see in the library and said, "I hear we're doing a wireless network." Well, yes. How did you know? Well, this student told this student. In our law school, word gets around. Okay, results. All three installed easily. And I was very happy about that. And I think you can't go wrong with several wireless products out there. As far as the speed tests, I'll be honest, Radioland was the fastest. However, in our tests, I didn't get 15% like PC Magazine. I had 7 on Cabletron. Aeronet was somewhat slower. As far as range, all three provided the same range relatively. Each had a degradation in single performance speed depending on how far we were from the access point. All three, you have, especially you'll see with the 802.11 products, they will drop from 11 megabits to 5 to 2 to 1, depending on the range you're at. The unit we chose was the Cabletron rollout. Now, what I'm about to tell you, the reasons what we chose are not necessarily what you may do. We had some specific reasons, and I'll show you why. Major reason cost. We're a Cabletron shop, okay? We got a major discount being a Cabletron, user. It was much less than both the Aeronet and the Radionet for us. The very important for us was the cost of the network cards, and I think they're around $140, $150, which is almost the cost of a 3-com wired card. So, in fact, we paid $120 for the ones we're getting to start with. Our Cabletron tech support history is very good. We had a good relationship with Cabletron. I can honestly say that their equipment has been, knock on wood, very good. Hopefully they don't hear me back in Hofstra. It's been working very well. And we're also now part of a campus-wide maintenance plan, and that's one of the reasons why we're still in the phase of implementing it. Otherwise, we would have actually been done, but in a way it's good because now our wireless network our product is part of the maintenance plan for the entire university-wide, which means free upgrades, and we'll talk about that in a second. Or upgrades are included, I should say, free. Upgrade path. That was very important to me. I didn't want to be stuck on 10 to 11 megabits per second, and Cabletron plans firmware upgrades to the product, which I'll tell you in a little bit. And 802.11b standard product. The more I got involved in this project, the more I realized that it should be important to be an 802.11b standard. And the Cabletron Roamer product, how does it work? Well, in a little bit I'm going to show you. I have it actually hooked up. Let's see if I can have the range. Can you all see this? Basically, you actually need to get, and I think Patty Monk's here. Hi Patty, how are you? Make sure the access points also need the network cards. So if you're planning to get like 30 points for your cards for your users and you're getting 30 access points, you got to get 60 cards. That's my main beef with Cabletron. The cards should come included. Cheap, this case. How does it work? Basically, it's a shared 11 megabit per second product. The transmit, like I said, the transmit rate will switch to a lower rate for more accuracy if needed. It often basically depends on distance. Overlapping access points allow roaming. That's what we were talking about, and Greg said, he thought it may have been overkill. Probably at that time you didn't think it was overkill. You probably wanted to make sure you kept the signal. That's what we're doing. I mean, I'll tell you how many access points we're getting in a second. I'd rather have overkill than have a dead area. So the idea, though, behind the Cabletron is that you can go, from point to point. And they use different channels. They have 14 different channels that you can set up. The idea behind the channels is so you don't have interference if you have two products near each other. So the laptop user doesn't see this. It can go from access to access point. Doesn't matter what channel they're on. It's the same usage. It's the same. I don't see anything. Security. I was talking with David. I gave him the abbreviation, the real name for WEP, which is Wired Equivalent Privacy. The cards we got were with a 40-bit encryption. You can also get a 128 card for a little more money. Lucent does the same thing. They offer a silver or gold card. You can also secure the access point so that you can do a couple things if you really wanted to. You could set up the access point to only accept encrypted data. You can also set up the access point to have a specific network name so that users just can come off the street and do that and access it. What is the 802.11b standard? In 1997, June, the first of the 802.11 standards were set up using DSS, which is Direct Sequence Spread Set. My water, please. This is what happens. I've been teaching classes and courses for a couple of years now at Hofstra in my spare time, and I get dry mouth after 20 minutes of talking. Please excuse me. And FHSS. In July of 1998, the IEEE proposed another specification, 802.11b. The specification moved forward only to 2.4 gigahertz DSS because that's where most of the vendors were going anyhow. The major improvement in the B revision was going up to rates of 5.5 and 11 megabits per second. The future speeds. Well, plans are under the way for operating the 5 gigahertz range and data rates up to 54 megabits per second. And Cabletron has just recently told me that if the standard gets ratified, we'll have our upgrade in about a year. Why go a wireless network standard as opposed to a proprietary product? Like I said again, I'm not here to diss or to speak badly of Greg's product. I think Radioland's a terrific product, and I could see why he chose it. In our case, it's the ability to have interoperability among wireless products. And what does that mean? Your 802.11b Lucent product, if you have one, let's say if anybody has a wire, will work on our Cabletron and vice versa. We've actually done that. My colleague I'm working on with this project went down to Virginia last weekend where they have a Lucent system, had one of our Cabletron cards, worked fine. However, we had a slight problem. We were trying to set up with Mitch Davis's Nokia system, and Steve can here tell you we, for some reason, couldn't get it working. And I'm sure there's some minor reason, and I'm sure we can get that fixed. But it's also Nokia as an 802.11b standard. So like I said, you can use one company's wireless on another one if you wanted that. What does that mean? You're not stuck with one system. If Nokia comes out with a better product that Cabletron can't match in a year, I still can use my Cabletron cards with that Nokia system. And vice versa, if I so chose. 802.11b is quickly becoming an industry standard. And companies that have 802.11b wireless products include 3Com, Compaq, Cisco, which bought Aeronet, Lucent, and Symbol, and Nokia. Why go with the continued? Many of these companies have joined together to create several organizations. And the first one is WECA, which is the Wireless Ethernet Compatibility Alliance. And their mission is to certify interoperability with the IEEE 802.11b standard. And they have actually a test so that they can promote, they have actually a Wi-Fi standard, it's called Wi-Fi, that says this product is interoperable with 802.11b products. And I'm going to just show you that I'm connected right now. And so boot up. And right now we're on the Cabletron system. Opening up. And there you go. That's the WECA website. And they actually have a list of certified products. And they also have a test. Okay? And they actually list products that are 802.11 that meet the Wi-Fi standard, and ours is one of them. Okay? They also have a test matrix if you want to go to the website. It's www.wirelessethernet.com. And they actually have a test matrix as far as the interoperability, and actually download it for your IT geekheads like me. No offense. Okay? So there's also another organization called WLANA, which is a Wireless LAN Association. It's more just informational. It just strictly tells you how wireless Ethernet networks work. What does this mean to you? I really, truly believe companies will have to be 802.11b compatible to have a place in the business campus LAN wireless market, and I even think they're going to stretch into homes. I really do. Too many big players. Cisco, Intel. They're also trying to cover all those bases because Cisco and Intel also are with home RF. But I really think 802.11b is going to be the standard. And if you go to the Wireless Ethernet site, they also have a link to an article on time.com. You may want to just go to Time directly. One of their users, one of the people that writes for Time, talked about the 802.11b. And also, and it talks about airports using it. And in fact, one airport is going to be using 802.11b. So you could actually, you come with your card and just, your 802.11b card, you can just plug in for a fee and you can access the internet at the airport. Cost of our project. 30 access points and 60 network cards were $24,000. That was with our discount. Okay? So we were a Cabletron customer, so that's why we got with that price. The data and electrical wiring of 30 access points, we figure is going to be $10,000. Cost of installation, we won't really know until the project's done. I've allotted $5,000. I might have been on the low end, but I'm never sure. You'll notice the one cost I didn't put in was hubs. I already have the switches. I already have ports on my switches, available ports to do that. You may not necessarily, but you may only have to just add boards to your switches and not have to necessarily buy a new switch. Maintenance plan, because we've got grouped under the university plan, it's only $1,300 a year for us, and that includes upgrades, the 24/7 tech support, and all that. Total budgeted costs right now, $42,000. That's my entire building. And that's also the clinic that I'm about to show you in a second. Right now, I'm going to show you a final walkthrough of the project. And it consisted of a Cabletron engineer, director of university telecommunications, and myself. We set up an access point in various locations of the building, and we walked around with a laptop with a wireless card. We tested the strength of the signal and the signal degradation, and it allowed us to see where we would permanently mount the access points. And now I'm going to show you my AVI file, and hopefully I can give you sound here. Oh, am I getting anything on the screen?
Still holding between 7 and 9. Right there. So everybody's take. That's where we have the.
Well, that's great.
Right, the second from right there.
Anybody? What? Yeah.
Hey, Matt.
All right. Well, I'll tell you what. I'm not going to waste.
5 to 6.
If anyone wants to see it, I'll show it to you afterwards. I'm sorry about that. I hate when that happens. You would think. Signal's affected by heavy steel and heavy concrete walls. As Greg found out. That's where we found any signal degradation. And we've got our share of steel and concrete walls in the building. The best signal performance when you're setting up an access point, as Greg did also, is when it's high as possible on the wall or above the ceiling. You also want to try and get it as high as possible to keep from vandalization. Okay? Results of the walkthrough. By the grace of God only, my estimate of 30 access points was pretty accurate. I needed 27 in the law school and 2 in our clinic career services building. I thought originally I'd have to set it up in classrooms, particularly, but it turned out I didn't have to set it up in certain classrooms. I covered it. And I did it more in hallways. Made sure the access points placement would be overlapping the signal and cut down on dead areas. I think we did that. I won't really know till sure, and I'll tell you the concerns. We'll also be able to cover our hallways, lounges, and our outside patio area as well. I'm sorry the video didn't show up, and I'll try and redo the resolution after this to show you. But we actually, that walkthrough that we did was actually outside in our patio area where we had already a Cabletron access point set up on our second floor lounge, and we were able to cover just about the entire patio area. Next is some building floor plans. I apologize for the crudeness of it, but since I was under a rush, I just wanted to show you where we put all the access points. As you can see, we're covering a very large, expansive area in the building. This is our basement, our first floor, our second floor, and our strangely put together third floor. I always wanted to make a comment about this. We did a third floor. This is the only area of the third floor. The rest of it is like an open quad. It's no building space. I don't know why they ever did that. And I can make fun of my university. Nobody else is here. Okay, based on SMU's implementation, we're going to have 25 network cards at the library on reserve, 2 to 4 hour reserve using DHCP. I can't say enough how big of a resource you guys have been and inspiration. And I think that's a really good way. Installation guide and software. In fact, after watching what Greg did, that's exactly what I'm going to do, is have it in a packet. And if they don't return the packet, we'll hunt the students down and kill them. We'll offer training classes on how to install and use wireless cards. We'll also have a web tutorial. A lot of our students like that. Why don't you just have it on the web? Fine. I have no problem with that. Students will be able to purchase cards through our bookstore. What we're going to do is we'll buy a certain set and number from Cabletron to begin with, put them in our bookstore. Hopefully our bookstore will just charge them the cost. Don't get me started on that either. The students will be able to purchase them either. Our loaner laptops for classroom use and our faculty use will be wireless. That's the idea. I already got several faculty with laptops who want to access our wireless network using their own. We use DHCP for our entire network. We used to have it just strictly for our public access ports in the library, and the computer center people finally realized, static IP is a real pain in the ass. And it took them long enough. We simplified the management of workstations and TCP IP addresses with DHCP. Before, you had to even manually configure the address in the workstation or manually put the network adapter address in the table for the TCP IP addresses available for the workstations. All you boot P users out there. DHCP eliminates the labor and the time consumption of setting up the addresses in TCP IP info on the workstation. It's been a big godsend. Concerns. It's not implemented yet. Yeah, I know, but the 2 months waiting for them to do the maintenance plan was worth it. Otherwise, we would be all set up. Will 77 access points be truly enough? I think so. I'd like to do a sequel in a year from now in Cali and Suffolk, because I really want to see Suffolk School, called Cali, Wireless, the sequel. And I'll let you know. But I'll also let you know on TechNords, for all you that are on TechNords. How many access points will run under heavy usage? That's the real true test I haven't done yet. How many users can I have on one access point? Cabletron says 256. I don't think so. I'd be happy with 50 to 60. I don't know until I actually do it. So, running out of DHCP addresses on our current subnet. Remember, we have public access network ports already. So we'll probably need to have a new subnet. We also have our clinic buildings on the same subnet, so we're going to move them over. As Scotty might say, Captain, I need more power outlets. I've given you all the power she's got. Not enough AC outlets in the building. We have to address that. We need more. And I'm also going to tell students, a lot of students do some of the craziest things. They don't have backup batteries for their laptops. I got still a lot of students who have hard drive, perfectly good computers at home with great hard drive space, and they save to floppies only. So I tell, a lot of the problems I've seen with laptops in the last year, and everybody in the IT who deals with students can also tell you, I've seen a lot of laptops with bad batteries recently, and I don't know why that is, but I'm going to tell them to get more batteries anyhow. Conclusion, follow the Whelan principle. Wireless should supplement, not replace your wired network. And I truly believe that. Okay? If you need to now wire your building, and you can afford to, or wire your classrooms, wire. He's right. A Cat5 wire network right now for the foreseeable future will be faster than 802.11b wireless. For now. Down the road, and I'd say in a year or two, I may rethink that statement. I know what you're saying. This guy's promoting wireless, and he's saying, wire, if you can, if you can afford it. But if you're like me, well, actually, let me caveat that. But there are areas where you can't wire. Lounges and outside patio areas. I highly look into wireless, especially if your resources, your points to resources are low. And, I would look at it also. If you can't afford it, and we couldn't, wireless is definitely an acceptable solution. Believe me, I was a skeptic when I first started this project. I'm a believer now. Prognostication. Wireless will become a mainstream part of networks in businesses, schools. It's already in heavy use in hospitals and a lot of colleges now. As you can see, there's some people wireless. I don't know if Steve's here. Stanford's doing a lot. Boston College, like I said, and the entire university is with wireless. Carnegie Mellon, it's coming. And homes. I have a faculty member who's using Aeronet. It's under the auspices of Dell. And I think that when Cisco bought Aeronet, they contacted Dell and said, why don't you offer our wireless cards at a nice cost to your Dell users? So he actually has a Dell desktop and a Dell laptop, peer-to-peer, 802.11b Aeronet, and he's happy as a clam. And for a law faculty member, that's hard to do. I'm sorry. I tell you something. I'm going to say something real quick. For you law faculty are out there, you guys get a bum rap. My faculty in my school are actually very good, and I like working with them on the whole. I'm not sucking up to you. I'm telling you the honest truth. My faculty are actually quite good, and I like working with them. 802.11b will be the standard in business and college wireless technology. Too many big players, and I'm going to say that again, too many big players are investing in money and effort in 802.11b. Cisco, and we know Cisco's getting involved, and you know Intel's part of the WECA, and Sercom. They see a market there. They see money, and they're putting their time and effort, and they're putting their weight behind it. And 802.11b, the standard for home use, well, like I said, I got a faculty member now. If they can bring the price down, which they are, I think it's a better solution than Bluetooth. I mean, Bluetooth, you got a 30-foot range, and you're talking your peripherals. Here, you have an actual chance to do basically your house, and have a wireless network in your house. The key is going to be the cost. I want to give my sincerest thanks to Matt Fuqua, who's the manager of Telecom at Hofstra, and Dan Yu, who's the associate, Tech Research Associate System Department. I couldn't have done this project without him. And I hope this was really useful for you. And we'll take some questions.
Are there any questions?